Hi everyone, today's topic is clusters, gaps, peaks, outliers, and the shape of distributions. You do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But don't fast forward so much that you miss out on something important. All right, so when we talk about the shape of distributions, we're talking about how we would describe the way that the data is spread out. There's three ways to describe the shape of distributions. The most basic one and typical one is just a typical bump, and that's called a symmetric distribution. Okay, and then the other way is skewed to the left, where everything's clustered to the right. And then the other is skewed to the right, where everything's clustered to the left. I know it kind of sounds backwards, but you're basically paying attention to what we call this tail when you're naming it. Okay, so for the symmetric, it's like the tails are even, so it's symmetrical. Skewed to the left means the tail is on the left. Skewed to the right means the tail is on the right. So we'll talk more about that. You're probably noticing that I'm using the word skew. Skew just means a non-uniform distribution of data. So when we say uniform, we mean the symmetrical distribution. So symmetrical distribution is our basic one. Most data, if it's symmetrical, will look like this symmetrical distribution. So we use it a lot actually with grades in class. So if your class took a quiz, you'll notice that most people kind of score in the B's and C's range because that's the average. And then you'll notice that on a quiz, there's only a couple of people that get the A's, and there's a couple of people who just do so badly that they have to retake a quiz. But most people are kind of in the middle. This is what we call symmetrical distribution because that's what normally happens. We also call it a normal distribution, because normally most people will kind of clump together in the middle, the average, and then you have some exceptional people above and below. So in a symmetrical distribution, data scores occur at regular frequencies with no skews. Skew again means non-uniform distribution. This is uniform. This is normal. The mean, median, and mode, all of our measures of central tendency, occur at approximately the same point, which is the middle. That's what's normal, typical. This is also called the bell curve because it kind of looks like a bell, the shape of a bell, roughly. Okay, so if you hear normal distribution or bell curve, it's the symmetrical distribution. Symmetrical means that's the same on both sides. So if I were to fold this bell curve on the middle, those sides would all meet each other. So that's what we mean by symmetrical. You can cut it down the middle and both sides will look the same. That's uniform. Skew is when it doesn't do that. So when we say skew to the left, that means that there's a little tail on the left. And there's a tail there because most of the data scores kind of cluster to the right. This actually pulls the mode, remember mode is most frequent, to the right, and also the median to the right, because that means you have a lot of higher scores. So it's going to pull the frequencies to the right, and the middle is going to be pushed to the right as well. This is, like we said, left-tailed, skewed to the left, and negatively skewed, because the negatives go on the left as well. So we pay a lot of attention to the tails. I know you normally look at what's clumping, so it kind of is the opposite of what you're paying attention to, but when we name it, we're looking at these tails here. Skewed to the left, negatively skewed, or left-tailed. And then the third distribution is called skewed to the right, so the tail is on the right. That means the data scores occur mostly on the left. They're clumped on the left. And the opposite of skewed to the left, the mode and the median get pulled to the left-hand side because it means you have a lot more scores on the left-hand side. This is positively skewed as well because positive numbers are on the right, and we also call it right-tailed. So we're looking at the tail. The tail is the skew. Okay, please make sure these three types of distributions and their example pictures are in your notes. And then we're going to talk about the individual scores in these data distributions. So caution, up ahead is data misbehaving. Remember, what's normal distribution is just a nice bump in the middle for your bell curve. Everything's symmetrical on both sides. However, when data is like misbehaving and doing some weird things, we do have other vocabulary words we have to talk about. So first up, a cluster. Cluster is when data scores noticeably cluster or clump together. Okay? So even in a normal distribution, there's going to be a cluster, but a normal distribution or symmetrical distribution, they're clustered in the middle. So any type of cluster is when you have a noticeable clump together. These are all vocab words, so make sure that they're in your notebook. Here's examples of clusters. They're clumped together. A gap is kind of the opposite. So that's when you have a noticeable space. You have a frequency of 0. None of these are being kind of voted on or appear in your data set. When there's a noticeable space, that's a gap. And then the other two words that you should know about is the peak and outlier. So a peak is when the data score shows the highest frequency. So that's usually our mode, so highest frequency. And then an outlier is when a data score is differing so significantly from the other data. Usually there's a huge gap between the outlier and the rest of the data. It's just so different from everything else. So cluster, gap, peak, and outlier are the kind of features we're going to look at when we look at our data distributions. So be sure that that's in your notebook, and we're going to move to some examples. All right, the shape of the data. So this question is asking, what is the shape of the distribution shown below? Is it symmetrical or is it not symmetrical? So something I like to do when I have box plots, since I can't see the data, is I'm going to draw what my distribution would look like. Here's a long tail, so I already know it's going to be skewed. And then I see my median is super on the left-hand side. It should be in the middle here, but it's not. So that means there's going to be a huge peak here, and it's going to trail off on the other end. So there's a tail. Remember, symmetrical means that it's like a bell shape. So it's the normal distribution. Symmetrical should look like this, same on both sides. This is not the same on both sides. There's a long tail on the right-hand side. So this is right-tailed, and it's also skewed to the right. We also call this positively skewed. Okay, so this distribution is not symmetrical because everything, all the tails are going to the right here. All your data is on the left. It's not distributed symmetrically evenly on both sides. Okay. This one, what is the shape of the distribution below? Is it left-tailed, approximately symmetrical and even on both sides, or is the distribution right-tailed? So again, I'm going to draw my distribution. And it kind of doesn't let me draw it, so it's going to go this way. And you should have said that it is right-tailed. The tail is on the right. Everything's clumped on the left. One last one for these. What is the shape of the distribution shown below? Again, I'm going to draw my distribution. Long tail over there. And so this is not symmetrical. And the tail is on the left, so it's left-tailed. All right, those are your shape of distribution questions. Now let's look at clusters, gaps, peaks, and outliers. So I have this question, which of the following are accurate descriptions of the distribution below? So you're looking for all the true statements, and you want to choose all answers that apply. There could be more than one answer. Let's go through it. The distribution has a peak at $12 per hour. There's a peak right here, That's at 11, 10, 11, 12. So that's true, it's at 12. It's good so far. The distribution has an outlier. Remember, an outlier means a data point that is so far away from everyone else. And it looks like it, there's an outlier right there. So there's 2 that are true. Go ahead and try this one on your own. Choose all the answers that apply. The distribution has a peak from 12 to 13 points. The distribution has an outlier, and also none of the above. Okay, so let's try the first statement. The distribution has a peak from 12 to 13 points. Remember, this is a histogram, so it makes sense that there's that interval. 12 to 13, is that your peak right there? No, that's not a peak. The peak would have been right here at this interval, 16 to 17. That's okay. B could still be correct. The distribution has an outlier. Is there some data that is just significantly different from everyone else? Well, I'm looking for a gap, and yes, there is something that's significantly different. That's the 0 to 1. And these are test scores in Mrs. Frine's class. So it looks like most people did pretty well, and maybe this person either was absent or didn't study, so that's an outlier. All right, this is our last one. Try this one on your own first. Pause the video. Okay, again, we're going to read through the answers and see which ones apply. The distribution has a peak at 41 years. I see a peak right here. Does it belong to 41, 40, 41, and 42? Yes, that one's good. The distribution has a cluster from 47 to 49 years. 47 to 49 years. Yeah, there is a little cluster here. A bunch of them kind of grouped together. These wouldn't be considered an outlier. This would just be a cluster. Yes, they're very different from everyone else, but an outlier is just like kind of a loner. This is the age of each teacher at Cork Prep. So these wouldn't be outliers. This would probably be like, you know, these, 7 teachers all maybe just are the same age and got into teaching at the same time. And then, you know, people a little bit younger than them didn't become teachers, and then everybody else is pretty diverse. So they're not outliers. They're just a group that are together. So outliers kind of have to be all alone. Okay, so that's clusters, gaps, peaks, and outliers. Have your vocabulary words handy in case you forget them. And just double check and make sure you have all the correct statements, because those are choose all. Let me know if you have any questions as you work on these, and I'll see you in class.